This is a derivation for the distance formula, the distance between 2 points on a Cartesian grid. If you pick 2 points, A and B, anywhere on the Cartesian grid, A has coordinates x1, y1, B has coordinates x2 and y2. And between x1 and x2, we have what's called the change in x. And between y1 and y2, we have the change in y. A line segment on a Cartesian grid you can think of as the hypotenuse of a right-angled triangle, where the legs are the change in x and the change in y. The change in x, of course, is the difference in the x coordinates, x2 minus x1. And the change in y is equal to the difference in the y coordinates, y2 minus y1. Now, to begin this distance formula, then, we will start with Pythagoras. The hypotenuse squared is equal to the legs squared each, the sum of the legs squared. In this case, the legs are equal to the change in x squared plus the change in y squared. Now, the change in x, of course, is x2 minus x1. And if we substitute that in brackets, it's x2 minus x1 all squared. The change in y all squared is y2 minus y1 squared. Now, we will let the hypotenuse be equal to the length of that segment, that length of segment AB, if you will. So segment AB squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. And of course, to find the actual length of AB, you need to take the square root of the whole thing. So segment AB, the distance of any line or any segment, line segment, in this case, AB is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. That is a derivation for the distance formula.